Hello, everyone. Thank you for attending our SAS Grid on AWS talk. My name is Laura Shepard, and I'm a go-to-market specialist on our storage team here at AWS. As you saw from the session abstract, we're going to be focusing on how FSx for Lustre and EC2 compute instances can simplify your migration to AWS and optimize your price performance of your SAS Grid deployment. By the end of this session, you'll be able to see for yourself, based on our testing and our customer successes, how to select the right instance types and file system options to support your SAS Grid workload. Along the way, we'll also look at a customer case study and show you how to get started with SAS Grid on AWS. But before we jump in, I want to start by talking for a moment about why SAS Grid on AWS. When I talk to people about why they moved to SAS Grid or are planning to move to SAS Grid in the first place, I get a variety of answers, of course, but I see a lot of common themes, including a desire to save money, to simplify administration, to consolidate licenses which are distributed throughout a company, all in a centralized infrastructure, to be able to scale centralized infrastructure from capacity and performance standpoint more quickly and easily, and of course the ability the availability and security benefits of a centralized implementation. And these are really very similar reasons that customers give for moving their SAS Grid implementations onto AWS. In the cloud, you can configure your performance, choosing from different instance types and storage performance levels to keep up with your data and performance growth over time. When moving your SAS Grid implementation to AWS, you can achieve the same high-performance analytics that you do on premises, but you also get the ability to spin resources up and down on demand, so you pay only for what you use without having to wastefully provision permanent infrastructure for your workload peaks. You also break the resource-intensive cycles of hardware procurement and reprocurement, of maintenance and administration, as well as file system setup and administration. As many of you experience, this can require a lot of specialized knowledge on your team, depending on how big and how fast you need to go. So to illustrate this, before we dive into the details of how SAS Grid works on AWS, I'm going to quickly walk through what T-Mobile did and their results to give you context that you can use as backgrounds to the concepts that we're going to be discussing. T-Mobile's original implementation of SAS Grid was on premises, and it ran on top of a Lustre file system that they built out themselves. Unfortunately, as those of you who have experience managing high-performance shared file systems, you won't be shocked to hear that their implementation didn't scale very well. It had very high management overhead, and it had subpar availability and performance. It was also expensive. T-Mobile estimated that their cost per tebibyte of their SAS Grid workload environment was about $800. So in an attempt to improve the situation, T-Mobile engaged with AWS and proceeded to move their SAS Grid environment to the AWS cloud. And then using Amazon FSx for Lustre and EC2 instances, they were able to improve their performance by 2x, cutting the time to completion for analytics runs in half, and reducing their cost per tebibyte of storage from $800 to about $140, which is an 83% reduction in cost. So now that you have some background on past success, let's move into the specifics of how SAS Grid works on AWS. Here on the slide, as you're probably familiar with, are the typical layers of a SAS Grid implementation. You have PWS, LSF that dispatch your submitted jobs and report on their status. You have your metadata servers that hold your metadata repository and definitions. Next, you have your compute nodes, each of which run a portion of any job that's been submitted. And finally, your SAS Grid libraries that store your enterprise data. When you take those layers and move them to the cloud, here's where they sit: in a private subnet within a VPC, a virtual private cloud, which just means that they're in a virtual network, private to you, and only accessible to you inside the AWS infrastructure. So your SAS clients access the environment over a VPN connection or via AWS Direct Connect, so your clients have a secure connection into this virtual private cloud. The connection can be from on-premises or from cloud-based clients. AWS Transit Gateway and Internet Gateway are the security entrances to the VPC, and you use these to control client access into your VPC. So inside the VPC, the PWS, the LSF, the metadata servers, and your SAS Grid nodes are all deployed on EC2 instances. And we're going to dive into the details of instance selection for your SAS Grid nodes in a little bit here. For all of your SAS Grid environments, we do recommend running your SAS Grid libraries on one of our managed file systems at AWS, specifically on Amazon FSx for Lustre. And you're probably curious how to size these, and we are going to go into that. But first, I want to take a minute to talk about why Lustre. Because you have a number of shared file system options. So why are we recommending Lustre under your SAS Grid implementation? First of all, it's the industry's most popular high-performance file system. It's proven in production under SAS Grid. It's been tested by SAS and by AWS. So why SAS Grid on AWS instead of on premises? Well, the cloud by itself brings a lot of benefits, as we mentioned already, right? Higher security, availability, performance, and lower cost than most on-premises implementations, as well as you get increased agility that not only has a big impact on your cost, but it also fosters innovation. And in the cloud, you can take advantage of managed capabilities that you don't have to provision and administer yourself. It's like a managed shared file system, which brings us to why FSx for Lustre. It is a fully managed file system. That means it removes the need for storage procurement, installation, maintenance, upgrades. FSx stands for File System X, where X can be any industry file system. We make industry file systems available as fully managed file services, and today we have Windows, FSx for Windows File Server, and FSx for Lustre. And what our customers like most about FSx is that they get to use proven, well-known industry file systems that come fully provisioned, and all they need to do is specify how big and how fast they need to go. These benefits are particularly strong in compute-intensive application areas like big data analytics, machine learning, and high-performance computing, which is why we see strong uptake for FSx for Linux across a number of use cases in financial services, for example, like backtesting and risk management, in healthcare and life sciences, for example, in sequencing or imaging analysis, in media and entertainment for transcoding and VFX workloads, in autonomous vehicle development like object detection, as well as in manufacturing and electronic design automation, and in upstream oil and gas in workflows like seismic processing, just to name a few. So coming back to SAS Grid specifically, let's look at how to size a SAS Grid environment on AWS. We're coming in at a point where we assume that you know your core count, because let's face it, that's where everybody starts so that they know what their licensing requirements and costs are going to be. But the very first thing after that we need to understand is the throughput requirements, because that's going to determine the performance of the underlying storage and the underlying instances that we need to resource the environment. So as you see on the slide, I've actually separated out SASDATA from SASWork and Utilock from your library standpoint. This is because while in the vast majority of cases, you will use FSx for Lustre for all three of them, and you will calculate their size and performance in exactly the same methodology, there are some exceptions, which we're going to cover later on. So for now, I'm just going to cover SASDATA. So for example today, just for demonstration purposes, I'm going to assume that we're talking about a 50-core environment. For 50 cores with SAS Grid, SASDATA throughput needs 100 megabytes a second per core, so you'd need data store that can deliver 5 gigabytes per second. And what we find is that for building multi-gigabyte file systems, the most price-performant option is going to be FSx for Lustre, and it's also the option that has the headroom for massive scale as you grow. So, to get our 5 gigabyte per second file system, let's look at our FSx for Lustre file system options and which ones could suit our needs. So FSx for Lustre customers have a number of options. We have SSD-based file systems that deliver sub-millisecond latencies and are available as persistent or as scratch file systems. We also have HDD-based file systems. Both persistent file systems, scratch, and persistent SSD file systems can achieve hundreds of gigabytes per second and millions of IOPS. And they support concurrent access to the same file or directory from up to thousands of compute nodes. For all FSX Lustre file systems, the performance of the file system scales linearly, and it's proportional to how much capacity you provision for that file system. Also, encryption at rest and in transit are available for all FSX for Lustre file systems. So persistent file systems have a higher availability than Scratch. With both SSD and HDD persistent file systems, metadata servers are automatically replaced if they fail, and data is replicated within an availability zone. Persistent file systems are therefore optimized for long-term, latency-sensitive, IOPS-focused workloads. Scratch FSX for Lustre file systems deliver the same performance as the fastest SSD-based persistent file system option, but they're designed for short-term workloads. On a Scratch file system under FSX for Lustre, file servers are not replaced if they fail and data is not replicated. So for all of the FSX for Lustre file systems, performance scales linearly per terabyte of provision capacity. In fact, the main difference between the various file system options is their baseline and their burst performance per terabyte of provision capacity. We'll talk about provisioning in the next slide and burst 2 slides hence. So it's good to note also that the supporting networking, compute, and storage resources scale to serve your workload's metadata and data requests. And I will reiterate here, in case you missed it, that all the SSD-based file systems options consistently deliver sub-millisecond latency. So if you take all this into consideration, because of the high throughput requirements and the always-on nature of most SAS Grid workloads, the optimal choice is going to be a persistent SSD-based FSX for Lustre file system. So I want to take a minute or two to dive a little bit deeper on the performance and the performance scaling of all the file system types, but then we're going to bring our example back to persistent SSD for more details. So, as I mentioned, FSX for Lustre file system performance is proportional to how much capacity you provision. Our highest performance FSX for Lustre file system option is 200 megabytes per second per terabyte of provisioned storage. So to achieve the throughput that we need, our 5 gigabytes per second for our 50-core environment, using the 200 megabyte per second option, we would need about 25 terabytes of provisioned storage. Now, if we go down to the 100 megabytes per second per terabyte or the 50 megabytes per second per terabyte of throughput performance options, then you would need a 50 terabyte or 100 terabyte file system, respectively, to achieve that 5 gigabytes a second of throughput for the 50-core SASDATA environment. That being said, something to consider when you're planning your environment is that the performance per terabyte that I showed you on the previous slide is the baseline performance. So many of our customers with bursty workloads find that they don't have to provision their environments to their peak performance needs. On the contrary, they can provision it to lower performance than their peak and use burst to achieve their peak performance throughput, which that can be a big cost saver, which of course is also one of the many advantages of running in the cloud. And running fully managed in the cloud does have a lot of benefits where Lustre is concerned. While a great deal of work is constantly being done by the Lustre community to improve Lustre usability, it has a pretty well-earned reputation of needing some specialized knowledge and care. I'd like to take a minute to compare the steps of creating a production Lustre file system on premises versus a fully managed one on AWS using FSX for Lustre. With on-premises Lustre, you need to have people who know how to build and run it, and this is a pretty specialized skill set. You need location with power, cooling, etc. Your capital equipment with the fun of days to months procurement and installation cycles, which of course start over every several years as you cycle your equipment. Then there's building out your ZFS packages and your Lustre server and client packages, followed by deploying your metadata servers, your OSSs, your OSTs. Then there's installing and configuring ZFS packages, pools, and file system parameters. And then there's tuning, which can be time-consuming all on its own. By contrast, I want to show you how easy it is to set up a file system on FSX. So here we go. You don't have to be a file system administrator in order to provision and create an FSX for Lustre file system. Starting from the AWS console, go to the Find Services box and just type in FSX, and that will take you here to the FSX console. You hit Create File System, select FSX for Lustre, and then scroll down and hit Next. File system name is optional. It's just a key value pair for the resource. I'm going to put SAS Grid. Next, for performance, we talked about the 3 different performance levels, 200, 100, and 50. We're going to do 100 for ease of math, which, as you recall, we're going to need a capacity of about 50 tebibytes. And then it calculates the performance for you, so you can't miss it. Next, we're going to scroll down to networking and security. And I can select the VPC I want to create my file system in, my file system security group, and the subnet where it will reside. Next, I select the AWS KMS encryption key to encrypt my data at rest. Then you scroll down, you'll see your backup options. And for persistent file systems like those we recommend for SAS Grid, you can take automatic daily backups on a schedule that you select, which is what I'm doing here. And you can set your preferences via the API, console, or CLI. These backups are file system consistent, they are durable, and they are incremental. And you can set a retention period so that you only keep what you need. Then there's a maintenance window. This is a 30-minute, once-a-week maintenance window where we may apply patches or security updates as necessary. Next, we have tagging. That's also optional. Most of our customers use this for standard file system tracking information, what type of file system it is, what type of application it is, who owns it, etc. So in our demo, I'm going to call it production. And then hit Next. And now you have the opportunity to see all of the file system parameters that you've selected before you create the file system. If they're correct, you hit Create File System, and within a few minutes, you're going to have a 50 tebibyte ready to go FSX for Lustre file system. No hardware, no scaling, no specialized skills. All right, now that we've determined our throughput requirements and we've used those to define our SASDATA performance, it's time to look at how we select our EC2 instances for SAS Grid. You have over 260 Amazon EC2 instances to choose from, so we wanted to give some guidance on how to narrow it down into the specific families that work best for SAS Grid. So best practices from SAS dictate that we need a minimum of 8 gigabytes of memory per core and at least 125 megabytes per second of throughput per core for SAS work and util lock. So to narrow down the field of instances, we ran a series of highly parallel network throughput tests from individual EC2 instances against a 100.8 tebibyte FSX for Lustre file system that had an aggregate throughput of 19.6 gigabytes per second. We used IOR to generate write activity to the file system using parallel threads and direct I/O. So we were bypassing the I/O buffers for a better picture of real-world performance. And we ran these tests in multiple regions in Virginia, Ohio, Oregon, and Ireland, using the multiple EC2 instances identified here on the slide. And based on these tests, we narrowed down the field to 5 instance families that we recommend for SAS Grid. That's the i3EN, the M5N, the M5DN, the R5N, and the R5DN. These are the instance families that align with the recommended requirements for SAS Grid, both for network performance and for memory. So let's take a closer look at just these 5 instance families. We ran an IOP write test using multiple threads against all of the instances in all of these families, all using FSX for Lustre as the backend storage system. So to achieve the maximum throughput per instance, accessing that persistent file system, the recommendation is using multiple threads or run multiple jobs per EC2 instance. Which brings us to our exception case that I told you that we were going to talk about earlier. So in most cases that we see, we're going to recommend FSX for Lustre for SAS work and util-lock, as well as SASDATA, all three of them. However, there are some circumstances where you're going to want to run SAS work and util-lock using a different approach. So I'm going to take a minute to look at how to identify when this may be the case and what alternatives you have. So not only is running all of your SAS Grid implementation on FSX for Lustre usually the right answer from a performance standpoint, it can also be much cheaper than building and managing your own Lustre file system on EC2 using either Instance Store or Elastic Block Store. However, we need to keep in mind that Lustre is a file system and it runs on a network. So it has slightly higher latency than you would with a local disk. So to maximize the throughput of Amazon FSX, you need to use multiple threads per instance. If, however, your workload is single-threaded, then you may want to consider using instance families that have Instance Store, local NVMe disks for both SAS work and for util-lock, since you can achieve the performance levels that you need to support those libraries using local NVMe drives in those instances when you're using single threads. So that's an exception to keep in mind when you're assessing how to structure your libraries on AWS. Again, it's not the norm. The norm is everything runs on FSX for Linux, for Lustre, and that is how we recommend you start assessing a migration. So with that, we've now covered why Lustre, why AWS, and how to select the right underlying file system and instances for your SAS Grid implementation. So next, let's talk a little about where you can go to get more information. So SAS and AWS have developed a number of assets that you can leverage to explore, size, and migrate your SAS Grid environment to AWS. And this includes SAS Global Forum talks, white papers, blogs, and detailed migration guidance. If you want a deeper dive on FSX for Lustre specifically, then please do make time for our sister talk here at reInvent that's called the Lustre Deep Dive Session. It's Storage 214, and that's going to be given by Daryl Osborne, who's our Principal Solution Architect for AWS File Services. And you can also find on our website information on AWS's very rich partner ecosystem, including many partners that can assist with migration and migration planning. I want to thank you for your time and attention. We covered a lot of ground in this very short time in this session. So let me just quickly recap my main points before we say goodbye. First of all, customers are migrating their SAS Grid environments to AWS to take advantage of the agility and cost savings of running these workloads in the cloud. Second, you can easily map your application-specific compute and storage needs from on-premises to your AWS storage and compute resources. Third, fully managed FSX for Lustre is simple to set up and run, and we recommend the persistent SSD option for your SAS Grid workloads. Fourth, there are a number of EC2 instance types that are well suited for SAS Grid implementations. And finally, AWS has up-to-date comprehensive resources to support SAS Grid migrations to the cloud. If you're unsure where to start, please reach out to sales support under Contact Us on the AWS landing page. Thanks again, and please enjoy the rest of your reInvent 2020.